Hello. So today we are going to we are going to learn about the chemical bonding. So chemical bonding, as we previously studied about how to predict the formula of a chemical compound. So the formula, it is the combination of two. It is a result of a combination of two atoms. Formula, it is written using the symbols generally, but it's all about the combination between two atoms or more atoms, or the combination of group of atoms, but for the purpose of forming a chemical compound. So when we say a chemical bonding, it is to say which type of force between two atoms combined together. For example, a word bonding, it's all about the force of attraction which keeps atom or ions or group of atoms or molecules together in a chemical compound. If something has formed, it means it has formed because of the combination of different types or of different atoms. So chemical bonding, it has many types. As in real life, we can see the bonds, the different bonds, because a word bond or bonding, a word bonding in chemistry, when we come in this real life or in this the physical life that we have, we can call it like it can have different synonyms or different similar words which you can compare with them, but each word must have its meaning. For example, I can say to tie. When something is tied, for example, this one, when something is tied, I can tie to make a knot. So, like this. So, if I want like to tie this arm, I can tie it like this. I can make a knot like this. Then I can move it as I want, in direction where I want. So, this is an example. For example, I can say the fasten. Fasten. Like if you see this button, I can fasten it like this and fasten like this, which means I'm bonding. What type of bond that I am using? I'm fastening using a bond made with the button, as you see it here. So I can say many things. They can mean to tie or to bond together. So the chemical bonding, it has many types in chemistry. As if I say to tie, if I say to connect, to ring, for example, I can give you an example here. If I can say a word to tie, to ring, right, to join together something. When I say connect, combine, I can say there are many words that you can say that they have the same meaning. You can say attach. Also link, I have said it. So if I say something is tied and I say something is joined together, there is a slight difference that you feel in your mind. When I use to tie, when I use to link, when I use to join, there are two things joined together. There are two things which are which are tied which are tied together like this. They are tied. They are tied together like this. So, or I can say these fingers, they are tied together. Attach. There is something attached to this one, like this and this. I can attach them using this scarf like this, using this scarf. So this is the type of joining two things together, or of bonding two things together. I can also use to join, to connect. To connect, I can connect two things like this. For example, if I have this and these chalks, they are two, I can connect them together. I can use this and then I make them connected. I make them connected together where I can just make like this. There is a connection using this. So, which means each bond has its own characteristics and its own properties, and also that's why we use different words, but for the same purpose. If it is to combine the two things, it is to close one another, or to close one to another thing. So if you are making them close together, you are combining them, you are adding them together. Attach, you can attach something. Tie, you can tie something. Fasten, for example, fasten, you can fasten together something. Fasten together, or you can fasten my button here for my shirt, for my coat. I can fasten it, which means these words they have. When I am using one of them, you feel there is a slight difference, but you feel like it is the same action. They do almost the same action, but when I say attach, something is attached to this. So you check that box, I have attached a paper on it. The box, they have even other items or elements inside, which have been combined together, but on the top, I have attached a paper, which means maybe I use the glue stickers, and then I attach it like this. It is there, tied. If I have tied it, I can say, you check uh, there is a chalk that I have tied on the box because the box was already closed, but there were one chalk missing like this. I have tied it on it. So all these words, they have almost the same, they are doing the same action. but they are different. When I use one word in these words, you feel difference. When I use tie, fasten, attach, join, ring, combine, and so on, there are many. There are many words that we can use when we want to mean this. So, as we can continue, I am writing this to show you that we are going to see the types of chemical bonding, but the word bonding will remain as the action of using this. I say these words, you can use them and someone can feel what a difference between each and every word here. So, but when I say connected, when I say joined, when I say linked, when I say tied, attached, fastened, you feel like you can explain yourself what happened to those things combined together. So even in chemical bonding, we want to have that spirit. That if we say a type of bonding, you have to know that it is a type of combination. It is a type of one atom joined to another. What type? Is it are they tied? But I'm using it as an example. But are they tied, fastened, attached, connected, combined? So we are going to see different names of chemical bonding, but when you are realizing how to differentiate them, you can you use this example. You feel like something, maybe it is like to say this type of bond, it is like to say tie, like to say linked, joined, attached. So that's how we have to catch up. You have to know that there is many types of bonds among chemical compounds. So let us see another example. There are many, even to nail. Nail it, something nailed. You know that when we want like to join together two woods, we use a nail. We make a wood like this, and then we put a nail here, and it goes inside and connect them together so that they cannot lose. So it's the same as here, but let me show. Let me start by giving you some definition, like chemical bonding. So chemical bonding, it is a force of attraction that keeps atoms that keeps atoms or ions or ions or molecules together together in a chemical compound, in a chemical compounds, or we can say or in solids. in solids. So we know that when we say chemical compounds, we don't feel like the stones also they are we don't take them as a chemical compound, but they are the they are chemically combined or they are compounds, but normally we don't say that we don't call them chemical compounds. Chemical compounds we use this word when we want to mean those which can react easily, which can be separated easily, which can be calculated easily like that. But also we know that also they are chemical compounds. But if we add the word solids, it means that you can differentiate like stones, like metals. Metals, we don't say they are chemical compounds. Chemical compounds, we can say acids, we can say salts, and so on. So we can say gas, but when we reach on solids, we always say they are solids. We know that all the universe is made of compounds, chemical compounds, but we can call them solids. So here we can say types of chemical bonding. Types of chemical bondings. So types of chemical bondings, as you can see here, a force of attraction that keeps atoms or ions or molecules together in a chemical compounds or solids. So it's all about what I was explaining. I was telling you that if we say to tie, to join, to ring, to attach, to fasten, what comes in your mind, it is that something, it is getting combined together with something, it is getting joined, it is getting close to each other. So, but when I use fasten, when I use to touch, when I use to join, when I use to attach, when I use to bind, there is even a bind. I can tell you, this is a bind. This is the bind. They binded these papers. They binded these papers using these spiral wires. They binded them together. This is another type of bonding. They bonded these papers using the spiral. They are binding. I can give you another example. It is this here, the staple wires. Staple wires. These are the staple wires in this book, and they wanted to join these or to combine these papers here, and they combine them using the staple wires. So the types of bonding, it is to learn which type of force that use to combine two atoms. So we each of these, like these spirals, like the staple wires, like a thread to tie something, it produces its own type of forces uh, when it is joining two things together. So in chemical compounds, we have like 5 types. We prioritize it, 5 types of bonding, of chemical bonding. Type number 1, you can say ionic Ionic bonding. Type number 2, we call it covalent bonding. Type number 3, we can say it is metallic bonding. Number 4, we can call it hydrogen bonding. And number 5, we can say that there is van der Waals forces bonding or van der Waals bonding. Van der bonding, van der Waals bonding. These are the main 5 bonds that I can tell you here, that I can tell you that we can learn as the beginners of chemistry, and then I also I'm also telling you that each bond here can have subtypes. They can have subtypes of chemical bonding. So, because in ionic bonding, you can find other small bonds which are there. They are minor. They are minor bonds, but also they show the difference in ionic compounds. And also in covalent bonding, also we will study one by one after. In covalent bonding, also before even we go to the subtype, there is other major types of covalent bonding where we call them. There is normal covalent bond, covalent bonding, and also there is one we call dative, or we call it coordinate. Coordinate covalent bonding. Covalent bonding. So here we cannot say there are subtypes as we can say in ionic bond, in metallic bond, because these ones they are more than to say they are subtypes, but they are the types of covalent bonding. There is normal and the dative or coordinate covalent bonding. Subtypes, I can tell you, subtypes, if you want to know about the subtypes of bonding, I can give you an example like sigma bond. But this you will learn this when you go in advanced chemistry. But I can tell you that there is other subtypes like sigma bonds, and also another type I can say pi bonds, delta bonds, single or double or triple bonds. There is polar and non-polar bonds. Those are the bonds that also exist, but they exist under these five bonds. For example, I was talking about sigma as a subtype of covalent bond, or anywhere elsewhere. I can say the pi bond, pi bonding, and also these may be under covalent bond mainly. Covalent bond has many subtypes and ionic bonds. But when we go in van der Waals bonding, we can find here other like I can say like a London dispersion bonding, or dipole bonding. We find them here. We will see one by one how we can explain one by one, but as per now, these are not very necessary because you are the beginners. Subtypes, they are not very necessary, but you have to know that they exist. They are there, which means you have to do some research so that you can have a sharp mind when you are thinking about chemistry. We are all running this so that you can be able to think critically when you are answering the questions or the scenarios. You make sure you have enough knowledge to answer scenarios of chemistry. So, like here, it is not bad to know that there are also subtypes of chemical bonding, like sigma, pi, like here in van der Waals forces. Also, you can find some subtypes like London dispersion, so and so on. So there are many. Also in carbon, we have they are double bonds. We can call them single bonds. In carbon, we usually use to say it is single bonded, or it is double bonded, triple bonded, and so on. But it stops to triple bonds, carbon. So, but you have to know that it is a type of bond. For the carbon, we call it double bond, single bond, we call it triple bond, but also when we go in those bonds, we see what type. Is it covalent? Is it ionic? Is it what? So majorly in carbon we find many are in covalent bond. So these two, the first two ones, they have many compounds than this. So metallic bonds, it is always found. It is always found in metals, in metal ions or metal compounds, metallic compounds. Like can see it in salt. It is also for the salt. Also, there are metals. In pure metals, we find also metallic bonding. We can also find them in metalloids. And metalloids also, when metalloids are under a certain condition, they can show the metallic bonding. So when we reach here, we will see how to identify if a metallic bond, if a bond is metallic, if a bond is ionic, if a bond is covalent, if a bond is hydrogen, if a bond is van der Waals bonding. So you have to know the difference between each of these to make sure you will be able to understand the scenarios, for example. So I can clean it here, and then we can continue by detailing these ones. Let's see in detail. Mhm. So the types. Type number one, we have seen that we we have to learn about type number one. It was ionic bonding. Ionic bonding, I can tell you, in ionic bonding, they are the bonds in ionic compounds. They are found in ionic compounds like this. So ionic compounds, uh, for example, you can see a word ion like this. The word ion, ionic, bonding. The word bonding, like joint or joining, as we have explained. So, ion, there is ionic, which means it is made of the combination of two or more ions, two or more ion ions, two or more ions. Generally, this is the general knowledge that you can have on ionic bonding. They are all about the ions. But when we enter into the characteristics and properties of ionic compounds, sometimes you can think that a compound is ionic when it is not ionic. We have some other factors that we have to look for, so to make sure we understand how to identify if if a compound it is ionic. Think let me again. For example, I can give you an example like iron magnesium. It is magnesium ion. It is ion. When it is combined with the fluorine or fluorine, it is fluoride ion or fluoride. Fluorine ion, it is called fluoride, as we explained in the previous lesson. So when I say that magnesium ion and fluorine ion, they are combined together, they will make magnesium magnesium fluoride. Magnesium fluoride. So magnesium fluoride, for now, you can say that it is ionic compound. You can say that the bond between magnesium and fluoride the bond between fluoride, magnesium ion, and fluoride ion, we can call it is ionic bonding. This bond, the connection between here and here, we can call it ionic, depending on the knowledge that we have here so far. We can call it ionic, because we know that this was having positive and this was having negative and this was having positive. They are two ions, and they are combined together. But we know in order to get a reaction, we have to have the ions, which means any compound, it is composed by ions. But when we say ionic compounds, we are going to see how to know this type of bonding. This type of bonding, you will see that it is a positive and the negative ions. It is a positively charged atom combined with a negatively charged atom. That is the first I can say. So, but when we see a chemical bonding and we want to verify if it is ionic, we say that it involves the transfer of one or more electrons from one atom to another. When we say the transfer, example, transfer, it involves the first one, or it involves the transfer of one or more electrons from one atom or from one ion to another in order to form a compound. Here, a word transfer is one which is standing for the definition of everything. It involves the ionic bonding involves the transfer of one. Let me write in one like this, of one or more electrons. So from one atom to another atom. You remember when we were studying the periodic table, I said that there is a group here which we called the donors, and there is another group that we called the receivers, which means donors will transfer electrons to the receivers, and receivers will receive those electrons. This is where ionic bonding will do what? Ionic bonding will be formed from when the donors have transferred one or more electrons from one atom to another atom. So this is what we call ionic. It may be from one atom or one group of atom to another atom or group of atom. So I think you are getting what this means. They involve to involve it is involved by the transfer of one or more electrons from one atom to another atom. So which means it's all about the metals. They donate they donate electrons to the nanometals like that. So it is where we can find it is where we can find the ionic bonding. That is one. It's like a property or a characteristic of ionic bonding. So, for example, if we say like a sodium, let me give you an example. Here we have sodium. When sodium it is going to combine with chlorine like this, they produce sodium chloride. If they produce sodium chloride, what happened? It happened when sodium changed into iron or got ionized and become like this. And then even this one, it got electrolyzed or it got charged, ionized, and it become the iron, which means this one will transfer, this will transfer to this, the positive in periodic table, the positive, they transfer, they are the donors. They transfer their electrons to the receivers, to the nanometals. When they, because this is one and this is one, they balance. They produce the sodium chloride. So sodium. So I can say sodium has donated one electron here. So by losing one electron, sodium atom achieves the stable electronic structure. Stable electronic structure. Electronic structure, it is when sodium here in electronic configuration, we say that sodium, it means that it has lost one electron. Sodium, it was 11. Sodium, it has 11 atomic number, and chlorine, it is 17. For sodium, if it becomes sodium ion like this, and this one become chloride, it means this one has been added to, this will be 18. It has been added by one electron. Came from sodium, for example. It is an example. Came from sodium, but sodium, because it has lost one, it was having 11, and now it has remained with 10. So if it has remained with 10, that lost electron had been added to the electrons of chlorine, which had 17, and now it has become 18 in electrons. What it means, to become stable for the sodium, let me show you. Sodium, it was like here, like this. It has 2, 3, 4, 5, 6, 7, 8, 9, 10, then had 11. This is sodium when it is neutral, when it is not iron. But let's say here, but let me do it here. But let me give you here, this is sodium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is sodium ion, which has 10, which has 10. This one has here 11. So when we say that by losing one electron, sodium, sodium atom achieves the stable electronic structure, the one which is equal to the neon. Even if you do the electronic configuration of neon, you will see the same structure because neon it has 10 electrons. So for sodium they say that it has become stable because it has lost this shell. It has lost this shell after after donating this one electron. It has lost one shell and it has remained with two shells only, and it became very stable, where it has remained with only the pairs. I don't know if you are following where it has lost one, and in its outermost shell, it was having only one electron, which means if it has donated one electron, it means it has destroyed its outermost shell, means it has remained with only two shells, which are full. When they are pairs only, it means it is full. It is full. So for that, while addition, we have an addition of electron, which is given, which is came from sodium, and it has gone to be attached to the chlorine. So the chlorine atom makes it achieve, it makes it to achieve also a stable electronic configuration, which is similar to, we can say, it is similar to argon, because argon is one which has 18 electrons, like argon, like this. Argon, it is 18. When we say here, we can change here, it is chlorine ion, which is 18, because it has received an electron from sodium, which has lost one. So 18 here, these are 10. It is no longer sodium. We are going to add another shell here, and then we make it chlorine ion. This is 1, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And also it has gained a stable electronic configuration, as we are seeing here, because it has in its outermost shell, it has only pairs. They are 2, 2, 2. So this is a type of ionic because there was a transfer of electrons from one atom to another atom. So this is what I can tell you for this first explanation. We are still on the ionic bonding, but we can also see the factors that favor the formation of or the factors that favorize the formation of ionic bonding. Let us see. And the factors that that favor the formation of ionic bonding. Let us see factors. The factors I can see the factors that favor or the factors that favorize or the factors favor the formation of ionic bonding. For example, there are many factors that you can say that they lead the formation. They lead to the formation of ionic bonding. For example, number one, one of the two atoms, one of the two atoms should have one of the two atoms should have the lowest ionization energy. For example, there are two atoms, atom A and atom B. When they are combined to make a compound of AB, this compound here, when atom A and atom B had been combined to form a compound AB, to know that it is they are combined with the ionic bonding, we will see if one of them it was used the lowest ionization energy. Number one of them must have one of them, one of two atoms must have the lowest ionization energy. This word ionization, it is a word to first explain what it means. I know that we passed through this, but ionization energy, it is the energy required by an atom to transfer or to donate or to receive to donate. It's just to donate an electron. This is ionization energy, or to become ion. When I say to receive, when an atom is preparing to receive an electron, an external electron, or a stranger electron, it requires first to become an ion. The energy of becoming ion, the energy used to become ion, it is what you call ionization energy. First, we have A and B. Here it was in this container, and here it was in this container. Now we are going to put them, and we are going to put them like this. We are going to put them in this container to make them A and B, and then here like this, A and B. This was A and D and B and B, like this. So if I pour this here and I pour this here and I want them to react in this in this bottle or in this flask. When they first reach here and they feel each other, that they can combine, there is energy produced for each one to make sure it prepares its legs, its or its joints, to make sure it is prepared to combine with that one. That energy of becoming ready to make a connection like this, that energy that an atom has used, it is what we call ionization energy. I don't know if you are understanding, because A, it will become positive, and B, it will become negative. Negative. This is before they get combined completely. This is the before they get combined completely. Before they get combined completely, for example, if this one it is sodium and this one it is chlorine, they will first, when they meet in the container like this, they will first do like this and this, which means they are now ready. They are now ready. When they are ready, they will try to start and combine. This is the second step. So the energy that the energy or power, the power that they have used to make like this and this to be ready to combine like this, it is the energy that we are talking about, that it is the ionization energy, because it has helped them to be ready to become ions. It is ionization energy. So here, to make sure it is ionic compound, this ionization energy, it must be the lowest of that atom. The lowest of that atom, For example, sodium, as you have seen, that it was first in this, like this. It was first having a like this here, like this. It was having one. When you see here, to donate this, it will use the lowest energy to ionize this, because we have seen that they have lost this shell. After losing this shell, in chemistry, they say that they can secondary ionize another electron to make it active. They can ionize this. But to ionize, for the second ionization, here, they will need more. This is for the first ionization. For here, they will use the lowest energy. But for the second, they will use more energy than the first energy, which was used to remove only one, or to make one electron in its empty. It was almost the empty shell, the outermost shell, because it was only one. Here, it was very easy to remove this than to and combine these pairs, or this pair here of electron, this lone pair. To destroy this lone pair, it will take much more energy comparing it to the energy used to ionize this one. That's why, because they have used this for the first ionization energy of sodium, it will use the lowest inner, the lowest energy. Here, that is 1. It will use the lowest inner, the lowest energy. So, but for the second, it will use more inner, more energy comparing. For this is the condition 1. But another condition is when they say that it will use the lowest ionization energy, but also that compound, that ionic compound, must use the highest electron affinity. They must use the highest electron affinity. So another definition here. Electron affinity. What is electron affinity? To see that to see the formation of ionic bonding, we must see that compound must use the lowest ionization energy. I have explained it, and the highest electron affinity, and the highest electron affinity. What is electron affinity? Electron affinity, you try to understand it and differentiate to ionization energy. Electron affinity, it is the energy absorbed. It is the energy absorbed. It can be energy absorbed or energy produced or energy emitted when an atom, when there is a combination of 2 electrons. I don't know how I'm going to explain it. So let us use this. This is the A positive and this is chlorine negative. I say that to become a positive and this become negative, it is there was a requirement of ionization energy so that this one can become ion and this one become ion negative and this positive. Then we are going to move this and get combined to this so that they can form AB. Here it was B, like this. They are going to form AB. So when this has met this, like this was positive and this, like this was positive and this was negative, and then they are combined together like this. There will be a fight. That fight, to make like this, it will produce energy. It may be absorbed or it may be produced, because when there are two reactions, there can happen an absorption to eat energy or to produce energy, or there can be the production of energy, of heat. We can produce heat because we have endothermic reactions and also exothermic reaction. Endothermic and exothermic reaction. Let us put reaction here and reaction here and here. For example, if A positive is going to combine with B negative, there will be a reaction during this reaction, it may be either endothermic or exothermic, or it may be neutral. It may be neutral. Maybe they don't produce any energy, but this is almost impossible in chemistry. It is almost impossible, and because some energy must be absorbed or it must be produced or emitted. They can emit energy or they can absorb energy. So, but when we use calculations in advanced chemistry, we use calculations to see if a reaction is endothermic or it is exothermic. Maybe you can get like the energy it was 0.000 point something, and you see that it was almost neutral, which means they did not produce any, they don't produce too much energy. Those are the reactions that you put and you see them reacting. There is no heat, there is no coldness, and so on. But if you are mixing two substances and you touch on the container like a beaker and you feel like it is becoming cold or it is reducing the temperature, it means it is endothermic reaction. If it is exothermic reaction, you will see heat, you will feel heat. For example, if you take water and mix with sodium hydroxide, water plus sodium hydroxide, they are water plus sodium hydroxide like this. Uh, Even if it is water, even if aqueous, sodium hydroxide. So this one, when it is a solid, it is more, it produces too much heat. Let us use solid maybe, like crystals plus the H2O. They will produce heat, or they will produce enthalpy. The enthalpy will be positive, the enthalpy will be positive. The heat will be positive here. Let positive, put it here. The enthalpy will be positive. But there are other reactions that you can make, and then you produce negative energy, negative total energy, negative enthalpy here. So that is an example of the compounds that you can mix together and they produce energy. And there are other which can become cold and they feel like they are reducing the temperature. But there are others that you can mix and you feel nothing. However, there is something happening there. There is absorption or there is uh, the production of energy or emission of energy. But when it is very small, it is hard to identify it except if you go and use calculations and use stoichiometry to make sure you can recognize if it was in part of endothermic or exothermic. So that was one. So the highest electron affinity, it means that the energy produced or energy absorbed when these two atoms are combining together. We can say that I can give you an example. For instance, elements such as aluminium, metal, aluminium metal form compounds most of which are not ionic due to the high ionization energy of aluminium. Aluminium, let me give you an example. I give you an example. I can show you some metals which are positive and they can form the compounds which are not ionic when they are positive and they have combined with negative. So that's why you have to understand this first definition, that to make ionic compound, you must have the lowest ionization energy and the highest electron affinity. I give you an example of aluminium. Aluminium sometimes it doesn't form ionic compound. I'm still explaining this about this. You know that aluminium. This is the. Let me do again periodic table like this. Yeah. Mhm. So let us see here like this. You see, this is group one, this is group two, this is group three. Where metals they stop from here and then we come this side. All of these they are the donors, and here to this side they are the receivers, which means receivers they are non-metals, and here they are metals. That's what it means. Which means here also they will be having the positive charges, and here they will have negative charges. Which means these ones they are called the cations, and here they are anions. We studied this in previous lesson. So let us look at here. This is the first group. This is the second group, third group, and the fourth. From first to third group, they are metals. So if they are metals here, if they are metals, they have to be charged positively. This is the number. It was number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So for aluminium, it is 13. I am going to give you an example. When it is 13, this is aluminium, for example, it has 13 electrons. We are going to do its electron configuration. This is 2, 3, 4, 5, 6, 7, 8, 9, 10. We are remaining by 3. This is 1, 2, 3. So look at here. And so in order to understand this, let me do another one for sodium here. So do one for sodium. This is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sodium, it has 11. It has 11 here. So, we are going to apply power or energy to remove this, and also to remove, because the valence of aluminium, it will become 3 plus, because in its outermost shell it has 3 single electrons, which means its valence, it will become aluminium 3 plus, because it falls into the metals, it will have plus, because it has 3 single electrons in its outermost shell. It will have 3 charges. Then this one, in its outermost shell, it have 1, 1, 1, and it will be positive because also it falls into metals or into the donors, and we have positive, positive. It will have positive. So let me show you this. There is the energy required. For example, there is the energy required. Let me use this. There is the energy required here to remove this, to take this off. And there is also another energy required to remove this, and another one to remove this, and another one to remove this, to make sure this will take reaction using its all valence electrons. And this is the electron valence for sodium. It is 1 because in its outermost shell it has only 1. So the energy that we apply here to remove this, it is very low comparing to the energy we will send to ionize this and this and this. This one has 3 ions in its outermost shell. I don't know if you are understanding me. This has 3 and this has 1, which means the energy to remove this and remove this and again remove this, it will require the highest energy. So, which means aluminium, depending on its ionization energy for the first ionization step, sometimes it doesn't form what? Ionic bond. It doesn't form the ionic bond. One, when it is sending electron affinity, its electron affinity, the energy to form the electron affinity, it will be very low. Even it can undergoes the endothermic or endothermical reaction. Endothermical reaction, which means it absorbs, it reduces the energy, the enthalpy here, it will become negative. Endothermic, it is where we see the total energy will be in negative with negative sign, which means it was very, very low. So electron affinity, when it is high, it produces heat. That's why I have told you that when you take sodium hydroxide, also but I'm not going to say it because sodium, if you take sodium granules only and you mix it with the pure water, it will produce too much heat. Don't do it. But let us take sodium hydroxide, maybe even if it is aqueous, if it is a solution. When you take it and you mix it with substances, even if you mix it with substances like water, they produce heat, which means the enthalpy will be positive. But those substances that you mix and you see that there is a change, there is a reaction took place, has taken place, and you feel like there is nothing happened when you're in terms of temperature and so on. For those, you will see that they produce the energy which is very low during their formation, which means their electron affinity it is low. And here for forming ionic bonding, we need the highest electron affinity, but ionization energy it is low, which means the characteristics of ionic bonding, it is the reaction which is quick because they ionize fast, because they use the very simple or very low energy to ionize, and then they combine. After combining, they combine violently. They cause heat, too much heat when they are combining. Those are the ionic bonding. That's what I can say. They can produce heat too much or small, but you make sure they have the electron affinity, which means sodium, aluminium, it will use too much energy to ionize to become iron. Sodium, aluminium, it ionize like this. Kubanga bubeera, because they are free. So, and this one, it become one. It is very fast to ionize one. And then during the formation, they will form. But because they came because they use too much energy, the electron affinity it will be lower than the ionization energy, and it will make that reaction to move slow. It will move slow because even this one it is already tired. It moves slow. It moves slow because it needs too much inner energy to form. It goes slow. It will go slow comparing to this. This one will go fast. It will send like this, but this one it will send like this. Pakanga until they reach there. So that's one I can tell you that aluminium, depending on its group they share or they give 3 electrons because it is in a group which has 3 electron valence. They need too much energy to take the first ionization. Uh, So, aluminium metal form compounds, most of which are not ionic due to the high ionization energy of aluminium. So, a large amount of energy, which means that the large amount of energy it is needed to remove all the three valence electrons from aluminium atom. So, uh, I mean that there will be a requirement of too much energy to remove 3 electrons of aluminium. So, the electronegativity also I can say that the second we're explaining about the factors. The second factor, that's the factor one. The second factor here Second factor, I can say that the electronegativity, the electronegativity, electronegativity difference of two atoms which are going to combine together, electronegativity of two, that their difference must be too high, must be high. For example, I have printed here, but in the periodic table, as we had it here, in the periodic table that we have here, this one, it will be another lesson when we are studying the periodic table, how it moves. The electronegativity. A word electron. Electronegativity. Here, it has the opposite of electropositivity. Electropositivity. I think those are the words also we can explain here. Electronegativity, it explains how much a metal tends to be a non-metal. That's what I can tell you. It means in a metal, how much is tending or how much properties of non-metallic it has. Electropositivity, an atom, how much is metallic. Electronegativity of atom, how much an atom is metallic. So let me give you an example. We have a boy, and here we have a girl, like this. A boy, a girl. Like this. So a boy and a girl, generally in genes, boy has uh, some female, or it is a male, yeah, and this is the female. A male has some feminine hormones, but they are too low. They are very small comparing to the girl. And a girl has some masculine hormones, which means the each every person, whether is a woman or is a man, in a man there is some properties or some feminine. In a man there is a feminine or the female characteristics or uh, the female composition in a man, but the male composition, they are too much. That's why even men, they have breasts but they don't grow. Like the female, they have breasts but they grow they grow bigger than that of man, and then they feel like yeah, it's like that. I can ask you how much a man is a female. Like a man, they are positive, and the female, they are, we can say maybe they are negative. So it's like to say electronegativity and electropositivity. It is like to say how much a man is a female and how much a female is a male, which means you mm, you can see some females, they grow and look like men, and they bring many properties of the male. And there are some men which grow and they have abundance properties of female. They look like a girl. So you see a boy looking like a girl, doing things like a girl, and growing some parts like a girl when he's a boy. Those things, it is where when it reaches where you can see maybe he can play two roles. He can go somewhere and play as a man and somewhere and play as a female. It's where we can say they are in periodic table. We can say metaroid. It is metaroids. Metaroids, they are those elements which falls in two parts, either in male or female. Female, as a boy can be a boy but look like a female, or behave like a female. It's like the metaroids. Metaroids, they are one side they are metals, and the other side they behave as an non-metals. That's an example. So when I'm telling you about the electronegativity, it is like to ask how how negative an atom is, how non-metallic properties, how many non-metallic properties an atom has. We calculate them. They are calculated in periodic tables. Many who has periodic tables, they can see that there is a difference. I have in my periodic table, but it is not around now. But I can tell you that in periodic table, as we are seeing here, like this, in this periodic table, from here we said that this is the third family where we see boron and aluminium here, and carbon and silicon. Then from carbon to neon and so on, or this side, they are non-metals, and from boron to here to potassium, lithium, and so on, they are metallic. Here they are positive. It doesn't mean that the positivity it stops from here. No, it means that there is a line that they drew here, which means the one which falls here, they are mostly negative. It's like to put like this, and then you put 0 here. When you put 0 here, we move here, it is -1, and here it is +1, +2. But when it is here, like in -100, this one, comparing 100 to 1, when we are coming to +1 here, 1, it is more positive comparing to 100 to 100. And here, when we have +100, so 1, it is more negative if we are going to -1. One, it is the most negative comparing to plus 100 plus 100. That's what we call electronegativity. Electronegativity and electropositivity, they move like this. Because when you are coming this side, this is the right and this is left. From right of the periodic table, moving to the left, right, left, from left to the right of periodic table, from left to the right of periodic table. Electronegativity, they increase. Electronegativity increase. Electronegativity increase. And electropositivity, they decrease. Because the most positive, it is one which is here. Here, the most positive, it is this, before they reach the 0. But if we want, for example, this is the 0, this is positive, and this is negative, For example, here there is boron, which is boron here. If we compare it with sodium, with lithium here, lithium is here, and boron it is here. 100 is here, and minus the minus 1 it is here. All right, let me put positive here to make it the same sense with this one. Positive here and negative here, as you see here. So this one, this is 100, and this is 1 plus minus 1 minus 100, for example. So lithium, it is more positive than boron, but even boron, it is positive. When we reach here, carbon, comparing the, for example, carbon, let us compare it with the fluorine here. Fluorine, it is negative, and the carbon also, it is a negative part. But when you hear from here, it is positive. This is 0. Fluorine, it is much more negative comparing to the carbon, which means the electropositivity of carbon, it is more than the electropositivity of fluorine. And electronegativity of carbon, because when you are moving here, electronegativity, they increase. Electronegativity of carbon, they are very less than the electronegativity of this. But electronegativity of carbon, electropositivity of carbon, it is much more than the electropositivity of this. So the solution is this. From left to right of the periodic table, the electronegativity increase, or the non-metallic properties increase. That's what I say. Electronegativity, non-metallic properties, the same. It's the same. You can say it means the same. And then electron positivity here. Electron positivity, right to the left to the right, they decrease, because from left to right, we are moving into nanometals. And nanometals, they have less electropositivity, which means electropositivity, it increases when we are coming from right to left, when we are coming back here. Right to left, electronegativity, they decrease, opposite to this. And electropositivity, they increase. So what does it mean? That when we say ionic bond, the difference between electropositivity and electronegativity must be too high. For example, this is let us look at this. This is helium, hydrogen. I move like this. Move like this, like this. So, for example, this is lithium in the same period here, the same row, in the same period. This is lithium, and this is the fluoride. If we say that lithium and fluoride, we are going to combine them together. And fluoride, lithium and fluoride. When we move from right to the left, electronegativity increase, which means in terms of electronegativity, lithium is less than this because from right to the left, electronegativity they increase, or non-metallic properties increase, electronegativity increase, which means lithium has less electronegativity compared to the beryllium, and more to boron, more to carbon, more to nitrogen, much more to oxygen, and very much more to fluoride, which means if we want the difference between, we are going to compare lithium and the oxygen, and the lithium and the carbon. If we are comparing, let us first compare these two. To compare these two, the difference electronegativity, which means electronegativity of lithium minus C electron, but let us see like this. The fluorine electronegativity, because electronegativity of fluorine and this, and then compare to the electronegativity of oxygen, minus electronegativity of lithium, like this. We are going to compare this. We are going to compare these two. This one, let's call it A, and this call it B, like this. So A, fluorine, it has more electronegativity than oxygen, which means this has a big number comparing to this, and we are moving the same number here. So which means the difference A will be greater than the difference of B. The difference of A equation will be greater than the difference in the B equation. It means this one, it is more ionic. A, it is more ionic comparing it to B. A, it is more ionic bond comparing to B. Are you understanding? A. It was equal to the fluorine, electronegativity of fluorine minus the electronegativity of lithium. And they say that this is the highest in this line. It is the highest comparing to this electronegativity of fluorine. It is greater than of everything you see here. From here to here, the one which has the more electronegativity, it is fluorine, which means the fluorine, when it is reacting to any of these, it has it is more ionic compound comparing to others, because here there is a condition saying that the difference between the electronegativity difference between two combined atom must be high. So which means this and this is the lowest in electronegativity, and this is the highest in electronegativity. This family and this family, when they react, they produce ionic bond because they have a very big difference in their electronegativity. That's what I can tell you. So try to think hard to make sure you understand this concept. That's what I can tell you. Try to do this. So, for example, a compound formed between an element of group A, like this. They are they are alkali metals. So, when they are formed from this and the group of halogen, these are the halogens, or group 7. So, these ones, uh, they are more ionic than one formed in group 2. Group 2, I can say, in this group 2 and this group. When we combine this one of these and the one another from here, they produce a compound which is more ionic comparing to when we take one from here to combine with another here, which means beryllium fluoride, it is the less ionic compound comparing to the lithium fluoride. Are you understanding it? It means that statement says that the group 1, when it is combined by the group 7 halogens, they form more ionic compound comparing to the formation between, or to the reaction between the group 2, like beryllium or magnesium, and the one of the halogens. The same. It means from here, when it is combined with this, they form less ionic compounds comparing to when it is in the first group, which means this and this. When you are squeezing, taking this to this, they are becoming less ionic compound until you reach where you no longer have any ionic compound. This is how you can compare the ionic properties of each compound, because I told you that each compound, it is formed when there is ions, but those are the two things that we can look for in order to make sure they are ionic bonds. When you are in scenarios, you may meet with a scenario asking about these bonds. So when you are here, you have to explain this concept, that to compare two compounds, the compound formed from group 2 to another group, maybe they can take this and this, like beryllium oxide. If it is beryllium oxide and they are comparing it to beryllium fluoride. Beryllium oxide, it is less ionic comparing to beryllium fluoride, and it is very less beryllium oxide. It is very less than lithium fluoride. Lithium fluoride, they are very ionic comparing it to N. Hydrogen, it form ionic bonds. It form ionic bonds. So uh, uh, those are the two factors uh, that that favor or favorize the formation of ionic bonds. Uh, let me let us see. Let's see something small, and we finish. In this lesson, we will learn only about the ionic bond. Then after, we will learn about the covalent bond. The covalent bond. So let us see. We want to see about the characteristics of characteristics of characteristic properties of ionic compounds. First, the first one I can say they consist of ions, not molecules. They consist of ions, not molecule. What does this mean? What's the difference to say ions and the molecule? Molecule. So uh, let me give you an example. Ions. Uh, this is the for example, magnesium chloride, or let's take this one, lithium or sodium chloride. Sodium chloride, it is ionic, and then we compare with this, or we compare with ammonia. Ammonia, it is the combination and the sodium and chloride. For example, ammonium, it is nitrogen and three hydrogen. Hydrogen, it is in family 1, but it is also in 2 parts. It can behave as a metal, and also it can behave as an non-metal, because hydrogen always it has this, but there is also the hydrogen which has negative. It can behave as negative and behave as positive. So we don't take it as a metal. We don't take it as a metal. We take it also as a non-metal. Sometimes they put here which means it belongs in halogens and also belongs in alkali metals, positive and negative. So if we see here, for example, we will not say that this has the ionic, it is an ionic compound. For example, you cannot say that this is the ionic compound because this is a molecule. It is a molecule. No, not a molecule. Let me see. Let me show you. A molecule that they said here, it's not this kind. They said like two. This is a molecule, but the molecule that they said here, because they combine they compared it with this is also a molecule. Already it is a compound and a molecule. But the molecule that they compared with this, we have two. It is like this. When two same atoms are combined, like chlorine and chlorine, they combine to form a chlorine 2. This is a gas. This is the chlorine gas. It is a molecule. We call it a molecule. A molecule. Even ammonia, we can call it a molecule because it is composed by more than one. It is not an atom. It is a molecule, but we call it a compound. It is hard. These words, I think we did not study them, but what is the difference between compound and a molecule? A molecule. A molecule, it is it is a compound composed by two atoms of the same type, two atoms of the same element. We call it a molecule. A molecule. And compound, it is a molecule composed by two or more atoms of different type or from different elements. That's what you can call compound. Comparing to this. So this is generally even this is a molecule, but we don't call it a molecule because it is composed with two types of elements of atoms, nitrogen and hydrogen. But if we say all the atomics, they are molecules, all the atomics, the atomic elements, all elements, all the atomic elements, they are molecules, we call them molecules. For example, N2, this is a gas. N2, this is a gas, a laughing gas, for example. We call it a laughing gas. And not laughing gas, it is nitrogen gas, not laughing gas. Laughing gas, it is a compound. Uh, Laughing gas is a compound, but this is just a nitrogen gas. And also, we can say hydrogen here. This is a, mo a molecule, not a compound. Hydrogen too. It is a molecule, not a compound, because it is the atomic element, or the atomic element. So if they say they consist of ions, not molecules, which means they are the compounds, the characteristics of ionic compounds. They are the compounds consist consist of ions, not molecules, which means there is a positive added to the negative. But this one, it is just nitrogen combined with nitrogen. They are all diatomic elements. They are found naturally combined together. They don't, even if you are producing, like if you are preparing like a chlorine gas, you will not get this, but you will get chlorine gas. Even if you are preparing nitrogen gas, you will get N2. It is the law of nature that this nitrogen or chlorine or fluorine, all the halogens, fluorine, chlorine, bromine, iodine, all of them they will be two like this. They are the molecules. They get produced as molecules. There are many, they are atomic. In the periodic table, many nanometers. Many nanometers, they are atomic. Uh, Even if you say oxygen, even oxygen is the atomic. You will not write oxygen like this. It doesn't exist when it is in nature, except when it is involved into reactions. But when it is alone, it is always the oxygen gas. It is a gas behaving like this. So this is the first characteristic property of ionic bond. Ions. They consist of ions, for example, this, not molecule, for example, two, oxygen, two, nitrogen, two. These are the molecules. Molecules, they are, and which means they are the compounds here. They are the compounds. But as we are saying, we are trying to explain the characteristics of ionic compounds. Ionic characteristics of and the characteristic properties of ionic compounds. Number one, they consist of ions, for example, sodium chloride, not molecules, for example, of molecules, chlorine gas, uh, oxygen gas, nitrogen gas. These are not ionic because they are not ions, but they are just the atoms combined together. So this is the characteristic number one that I can tell you. Another thing it is that number two, ionic compounds they are electrolytes. They are electrolytes. Electrolytes, which means they can be electrolyzed. They can be electrolyzed. Electrolytes, they are the substances which can be electrolyzed. The electrolyzed which can be electrolyzed. Electrolyze, it means the substances which can be stimulated to produce electricity. They can be stimulated to produce electricity. For example, they can produce electricity or they can conduct electricity. So, electrolytes. There is also, we can say, electrolytes. There are many types of electrolytes. They are also the method that they use electrolysis to separate two two atoms. For example, sodium chloride. This is a salt, especially the table salt. That's the salt that we eat. So if they put it into, if they mix it, they put it into water. For example, they put it into water to make a solution. For example, if you connect electricity here, you will see this and the negative. It is another lesson. This one. If it is like here, and you put it electricity, positive and negative, and you put these wires into a container of sodium chloride aqueous liquid. It will separate sodium and chloride. If you want to absorb or to prepare this, you can use this method of electrolyzing. So these are some of the advanced chemistry, not on this level, but here what I'm asking you, it is just to catch that it is a characteristic that the ionic compounds, they are electrolytes. The other things of electrolyzation and so on, we shall see them in the next chapters. But electrolytes, they are those which can be separated by electricity, which can be ionized by electricity. Even if you put this electricity into this gas, there is nothing will happen. But if you put this into this solution, you will see the ions, they are separating themselves because they put two bars. The one which accepts positives and the one which accepts negatives, electrodes. You can call them electrodes. These electrodes, there are two. One which accepts positives, you will see them, which is charged positive, it will accept negative. For example, chlorine minus. And this one will accept sodium. If you want to remove this, you will check the one which has accumulated to or concentrated on this positive, and you will know that the one which has gone to this, they are the one which are negatively charged. If you are sodium chloride, you will know that here there will be chlorine, and you make sure you remove it if you wanted to prepare this. But if you wanted the pure sodium, also you will go and check here and collect pure sodium on this side. That is It is very simple. That's how I can explain you about this, but this is another lesson which we are not going to study now. So, so I can here I can give you some example. Uh, if we put like when we dissolve a substance in water and or we melt them, you can melt. So for that, we can and we put electricity. The electricity can be conducted. So electricity can be conducted. You have to know that it has the ionic characteristics. So and then and then uh, it can decompose them. It can separate them. We can use the electrolysis method to to separate them. Now I give you an example here. Even if you take salt lithium and then also lithium fluoride like this, it will be the same. It will give the same. Only we normally use these table salts like this sodium chloride, especially this one, and sodium fluoride, this one also. You can use it. There are other many examples that we can say. So number three, let us see. Number three, let us see the characteristic property of ionic compound. We can say they are solid of high melting point. They are solid of high melting point. So number three, characteristic number three. Three, they are the solids of high melting points. I will not explain too much about this, but you have to know that the ionic bonds, even if you say like a salt, a table salt, they are very soluble in water because if you take salt that you use at home and you mix it with water, it doesn't take too much time to be a solution, to disappear and become like water, to become a solution. It takes a very short time. But if we want to melt water, like to put water into a container, to put salt into a container without any water, and then you cook it until it melts, it will take, I think you did never see that, but it is possible. Only it takes too much energy so that it can melt. The one which melts faster, it is the sugar. But sugar, we cannot call it, it is ionic. Sugar, it takes, if it is ionic, sugar we cannot put it into the ionic compounds. If there is a sugar which has ionic compounds, they are inside, but the entire composition of sugar, it is not ionic. because its melting point, it is not too high, but it is higher than gas and so on. But I know that around 100 can melt sugar. 100 degrees Celsius can melt even a sugar, or 100 like that. It can melt sugar, but when we see for these solids, for the ionic compounds, they are solids with high melting point. For example, I can give you an example of salt, table salt. That is an example of ionic compound. Ionic compound. There is table salt. Then we can say sodium reacting with all halogens like sodium bromide and so on. They are always strong. They look like salt as you see salt, and also they have high melting points. So that is an example. I can tell you another one, number 4. They are insoluble in organic solvent. Organic solvent, the word solvent, it is the opposite of solute. What is solvent? It means, for example, I'm going to mix salt plus water in this cup. If I want to mix salt and water, I put 2 cups of salt here, and then I put too much water, which means the one which makes the salt, it is what we call solvent. The one you use to mix something, some substances, it is always called the solvent. The one which you use in abundance or in a big quantity, it is called solvent. When you are mixing 2 things, and one it is and you are making like a solution. When you are making a solution and you want to use one in a big quantity, it will be called solvent. When you are making a solution, for example, you are trying to make a porridge, and you put a flour of maize into a saucepan, and then you will add the water to make sure you make a solution, which means the flour in the saucepan, it is solute, because it is one you take in a smaller quantity. It is a solute. So, and then water that you are adding there, you are adding there, it is water, it is solvent. So which means salt, it is solute, and water, it is solvent. So they are insoluble in organic solvent. For example, organic solvent, it's like to say in alcohol. For example, sanitizer. In alcohol, when you put alcohol into salt, you may not see that it can melt it. When it is pure alcohol, it is not easy to melt the salt. But they are very insoluble in water. But they are very soluble in what? In water. So they are very soluble in water. We shall run some of them. They cannot be very soluble in water, but many of them they are soluble. They are very soluble in water. You take salt. The salts they are very soluble in water. Even the sugar, the way it is very soluble in water, it may be having some properties of ionic bonds. But in sugar, we find it different. We find different and many types of bonds, not only ionic bonds. But the way it is soluble in water, it contains some ionic bonds. So uh, I think for this point we can finish here. That's it. We are remaining with a few things to finish with this. As you see, what we can say, we cannot leave what we call the factors affecting the strength of factors affecting the strength of ionic bonds. For example, here factors. Ionic bond. So number one, we can say the size of cation. Number one, you can say size of cation. Size of cation. You remember what we call cation. If we say the size of cation and anion, let us add an anion. You remember about the cations. Cations, they are metals, for example. They are those which have positive, they are the positively charged, the positively charged ions. And then anion, they are negatively charged ions. For example, sodium and here chlorine minus, magnesium positive, 2 positive, and bromide, and chloride, bromine, like that. So, uh, like this. These are some examples. So, uh, about the size, the factor affecting the strength. Now, affecting the strength affecting the strength of the ionic bonds. Affecting the strength of the ionic bond. The number one it is the size of the anion. So ionic bonds are stronger when the size of the cation is big, and that of the anion is more. For example, if this is big and this one is small. Huh. Let me go back here in order to make this quickly. This is the periodic table. In the periodic table, we will start this in the next lesson. In some next lessons. From here, how the atomic size varies across periodic table. How the atomic size varies across periodic table. From here to here, it is right to left. It is left to right. When we go like this, we come from left going to the right. The atomic size here, the atomic size when we are in the same period, the atomic size reduce. Why? For example, here we had lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon here, which means if we say from left to right, in the same period, the atomic size decrease. Atomic size decrease from right to the left, from left to the right. Atomic size decrease because first they have the same number of shells if they are in the same period. These are called the periods. These are called the families. Like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, they are in the same period. They are in the same period, which means they have the same number of shells. For example, if I say electronic configuration of lithium, it has 3. It is done. Let us do the electronic configuration of neon. Neon, it has 10. 3, 4, 5, 6, 7, 8. No, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is lithium, and this is neon. Neon is 10, and this one is 3. Lithium is 3, and this is 10. And for the first shell, lithium has 2, and this one has also 2. For the second, lithium has 1, but this one has 8. However, lithium it is lower in terms of atomic number than neon, but they have the same number of shells because the rule of shells, of forming shells, they say for the first shell, you put not more than 2 for every electronic configuration of any element. And for the second, you fill with 8, but not more than 8. The maximum, it is 8, which means neon has reached its maximum, but it is completely done with its electronic configuration, if you are understanding this. But let us look at here. Why do we say that from left to the right of the periodic table in the same what? In the same period, called period, the same law. It is called the period. If they are in the same period and you want to check the size of, of atom, how it varies across the periodic table, from left to the right, they decrease. For the reason why, you see here, we have the number of electrons, always they are equal to the number of protons. When it is the number of protons, when it is the row, when it is when it is neutral, not low, when it is neutral. So for that, it means that here also we have 3 positive or 3 protons, and here they are electrons, they are 10, which means we have even 10 positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see how the positivity of neon are very many in its nucleus than lithium. In lithium, there are 3. And in neon, there are 10. So, and the positive, they attract electrons. The positivity of this, there are 3. Here, there are 10. Remember that all the mass of the atom, it is held by the nucleus, where it is the addition of protons and the neutrons. So which means here, it means that these positive, they will squeeze electrons, because electrons, we take them as massless particles. So if this nucleus is very strong, it will squeeze this size of atom, comparing to this which has the 3 protons. It means that to say that from left to the right of the periodic table in the same period, the atomic size decrease, it is due to the increase of the number of protons in the nucleus when the number of shells, they are the same. When the number of the shells, they are the same. That's what I can say. But if it is like a lithium, maybe we can be comparing lithium, we can be comparing it to the chlorine like this. It will depend, because they are not in the same period. Here, this is period number 3. Here they have 3. For example, for the sodium, it has 3. But if you are comparing sodium, atomic size of sodium and chlorine, you will see that sodium, it it will have bigger than this because they are in the same period. But when you are comparing this to this, you have to do some research. If they are not in the same period, you have to do some research. But it will always depend. We always ask questions depending on the same period. If they are asking you how it varies, you explain it depending on one period in the same period. We don't jump period because when you jump a period, when you are comparing two atoms in different periods, you have to do some experiment to see if which one is bigger. You can do some research or you can do some experiment. But when they are in the same period, you use this general assumption that from left to the right, the size decrease due to the increase of positivity in the nucleus. That's what I can say. So let us move. We have talked that when in the periodic table, still in the periodic, they say that if the size of the size of cushion, if the cushion must be having the big size, which means the big size, they are those which are very close to the leftness of the periodic table. These which are in the first, they will fall in those with the big cushion atomic size. I think we are matching with all we explained. We explained that the one which is here, it has a big size in terms of atomic size, comparing to the one which is in the right of it. The leftness, when you come to the left, the atomic size increase. When you go from left to the right, the atomic size decrease, which means the one which is this side, they form the very strong cushions. An anion must be less atomic size. Less atomic size, the cushions, they are halogens which are here. And 7 is the group. They are the ones which has the smallest ion. We know that this part does not react. We don't touch it when we are talking about the reactivity. But for the halogens, they are the one which has the smallest size here, due to its great positivity in the nucleus, or the number of protons. They are too much. They squeeze all electrons, and they make it very small. They become gas. Where here, you can see here they are gases, and they are non-metal, and they are gases. But here they are metals, and also they are solids. You can see the granules of sodium. You see of metals. You see them. They are tangible. But here they are air. They are in airs, chlorine, fluorine, nitrogen, all, which means they are very small. They have a very small size due to the number of protons which squeezes its shells by attracting the electrons which move around around them. So another another one another one it is to I can another factor affecting the strength of ionic bond. As I've said, the first one is the size of the cation and the anion. So where we said that ionic bonds are stronger when the size of the cation is bigger and that of the anion is smaller, due to the low polarization is more ionic than, for example, if you say the sodium chloride, it is more ionic uh, than lithium ion, lithium chloride. Let us see here. Sodium chloride, uh, it is more stronger than lithium chloride. So it is lower. Sodium chloride is more ionic than lithium chloride. Lithium chloride is up there like this, and then sodium is down like this, and they are in periodic table. So in periodic table, because the chloride is here and fluorine is here. Lithium chloride, it is not much ionic comparing to the sodium chloride because this one I did not tell you how the atomic size varies depending varies across the families from top to the bottom. From top to the bottom, atomic size increase. Atomic size increases. Atomic size increases due here. The reason you give it is that due to the increase in the number of shells. They increase the atomic size of this trending or across from the top to the bottom of the same family. Which means the atomic size of sodium is greater than the atomic size of lithium because lithium it is in the second period, and this is in the third period, which means lithium has two shells and sodium has three shells. Just you explain that from top to the bottom, the atomic size increased due to the increase of the atomic electronic shells or energy level. When they increase, also the atomic size. So which means when the size of cation is bigger than another, and they have the same nanometer, it means you will compare these two. Which one has the big atomic size? And you will make sure you explain that the one with big cation atomic size will be more ionic comparing to the one with smaller atomic size as a cation. But Remember that here they compared when these two of the first family, they have combined with the same element here, which is chlorine. So that's one. That's another thing I can tell you. Another thing is the number two for the factors affecting the factors affecting the factors affecting the factors affecting the strength of the ionic compound or ionic bond. We can say electronegativity. Number two, here what was number one. And number two, electronegativity. So, or electropositivity. You can say electronegativity, electropositivity. But how? I can say the difference between these two. We can also add the electropositivity. Electropositivity. I explained this in this lesson. So when the difference it is big, electropositivity and the electronegativity. When the difference is big, it means the ionic bond is strong. Because in the periodic table here, as you see, when the distance between one and another one, two atoms, as the distance in the periodic table is increasing, also it means it is increasing. It is the increase of the ionic bond strength, because when this one it is distance to this, it means even their electropositivity and electronegativity difference, the difference it will be bigger, it will be increasing. So that's what I can tell you about this electronegativity and electropositivity. Their difference must be big to make sure that the bond has enough strength. We talked about the polarization. Maybe it is the last one that I can talk about in this lesson. What we call the polarization. Polarization, I will not talk too much. Maybe we shall talk about it in the next lesson. But let me give you something about polarization. What is the polarization? Polarization. Polarization, I can tell. So, information of ionic molecules, when two opposite charged ions are going to close to each other, there is some reaction there. There is some reaction. For example, if this is an atom, this is an atom, and this is another atom. Maybe this one is sodium, and this one is it is chlorine. We still get the same examples. If this one, they are coming together like this, like this, like this. They each time, like this one has dislocated to here, displaced to here, and this one has displaced to here. And they become positive and this negative, they are about to combine together. And this one, there is a way this one will come, it may come like this, and this it will become like this. Let us see that one has entered into another. It was here, and it has strengthened to enter into this. This is what we call the polarization. It become polarized. It become pole. It changed the form. It deform the deformation. It make a deformation, making a deformation during the chemical reaction. This is what we call polarization. Polarization. If it's something, it is polar. If they say that an atom it is polar, it means that it changes its shape when it is reacting. We call them depolarized. When ionic bonds, they get reaction and they change their form. Two atoms may meet when one of them, maybe it is one which will be polarized, and other one will remain strong. For example, I give you an example. This is this book, and it is going to meet with my fingers. They are going to combine together. It's like this. So if it is like this, can you see my fingers? Can you see my fingers? They have entered there. My fingers, they remain as they are. And this book has changed its shape and they have combined together. My finger did not change. Which means this book has polarized if it is in terms of atoms. This had been polarized, but this did not get a reaction to be polarized. So let me show if all of these have polarized. So I can make like this. You see, then my fingers they have folded themselves and they changed their shape. They were like this straight, and now mm, they have they have changed. All of this atom and this they are polarized. They are polar because the one which not get polarized, they call them non-polars. So we run like that. But in advanced chemistry, we run many things: shape, angles, and so on. How it gets polarized, at what angle, and so on, like that. But this is what I can tell you as the beginners of chemistry. Uh, but even in advanced chemistry, you will be adding small if you have understood this. So maybe today we can stop from here. Only I will come. We have talked about ionic bond. I will come to explain covalent bond, or if possible, if time can allow, I can explain like two, or I can explain it all in one lesson, because we have explained the ionic bonding, and we will see covalent bond, which has two parts: dative or coordinate coordinate covalent bond, and also normal covalent bond. And also we will see hydrogen bonding, and we see metallic bonding, and the van der Waals bonding. And then after, we will continue with nomenclature. But let us first come back and cover this this lesson of chemical bonding, and when we close it, and then we go to how we name the compound. Thank you so much for today, I call you to subscribe.